Now, as a follow-on to question 5a part 1, we're asked to try and show some other isomers of compound A that may have been possible and why they didn't meet the requirements. Now, the good thing about this obviously is that you probably already drew some of these when you tried to sort them out. Now, this is the one that I initially drew when I first looked at this problem, and it seemed to fit some of the requirements, but obviously it didn't meet them all. That's having an aldehyde group at this end and having these two alcohol groups coming off. Now, when they're Now, when this reacts, because we've already got OH group with KMnO4, because there's two OH groups already there, we're likely to see that being oxidized to a carboxylic acid. So we'll have 4 carboxylic acid groups. Also, there's no reaction. This would not react with dilute sulfuric acid and give the same product that is indicated in the reaction scheme. So where it says reacting with dilute sulfuric acid on heating forms C4H6O5, we wouldn't get a compound that fit that with that reaction. So it doesn't seem to work on that basis. Other possibilities. Okay, and if we were to react with dilute sulfuric acid and get an OH and an H adding across this double bond here, irrespective of where we put the OH, we would not get or the H, we would not get an enantiomer, so this one wouldn't work for that either. Okay, so you just need to explain that obviously as well. Okay, now with this structure we've put 2 double bonds in there, so this is a third possibility, I suppose, but if we were to react that with dilute sulfuric acid, it wouldn't produce the right formula for compound, I think it's C4H6O5. So if we were to react that with H2SO4, that wouldn't. Instead, we'd end up with something like this, where we've got, you know, 2 OHs here, OH here, 2 OHs and OH here, so 6 oxygens, but we'd end and 8 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8. And yeah, so this one doesn't work either. So any of those two would probably be sufficient. Okay, that's that question.